Okay, we need to use a special substitution to find the integral of x ln x squared plus 7 over x squared plus 7 with respect to x. So with this, we can go straight to the substitution, but we need to get the right substitution. So if the thing you're trying to integrate contains, so if it contains ln of some kind of f of x, try substituting u equals ln of f of x. So we're not just going to make u the x squared plus 7, we're going to make u the ln of x squared plus 7, because that should be a nice derivative that should help us with some of this to make it look a lot nicer. So we have u equals ln, in this case our f of x is x squared plus 7, ln of x squared plus 7. So hopefully, I could do a formal chain rule to differentiate this, but hopefully you remember that if we had, say, y equals ln of f of x, the quick way to differentiate that is you have dy by dx equals f dashed x over f of x. You don't need to remember that, you can use the chain rule, but this is what I'm going to do now, so that's just a little recall box. So du by dx in this case is f dashed x, so as in the derivative of the bit in the bracket, which is 2x, over f of x, x squared plus 7. So that must mean that dx, or du, equals 2x over x squared plus 7 dx. So that must mean that dx, to make dx the subject, well, we're going to have to send the x squared plus 7 up there and a 2x down there. So equals x squared plus 7 over 2x du. So that is our substitution for dx. So then that is going to transform the integral for us really nicely. Actually, it's going to help us with two problems. So I won't spoil the surprise. We'll see in a sec. So if I called this the integral, I for integral, so now our transformed integral equals, well, it's the integral of x times, well, ln of x squared plus 7 was u, so x times u over x squared plus 7 times, and it's the dx that makes things so good. So this dx is x squared plus 7 over 2x du. So look at all the stuff that's going to wipe out. So let's start with the x squared plus 7s. Cancel, cancel, 1, 1. Then look at the x. That x with that x, 1, 1. So we end up with 1, and there's a u, and there's a 2 on the bottom. So it's literally the integral of a half of u with respect to u, which is the same as a half of the integral of u du, equals a half times the integral of u with respect to u. So that is really quite friendly. So equals a half, well, this is going to be u squared over 2, u squared over 2, plus the constant of integration equals u squared over 4, so I'm going to write a quarter, u squared, plus the constant of integration. Well, u is ln of x squared plus 7, so now we need to put it in the original terms. So final answer equals 1/4 times ln x squared plus 7, and we need to square all of that, and we need to not forget the constant of integration, and that's it. Don't be tempted to think you can use some sort of log rules on this bit, because it's not going to work.